Hello, welcome to our video. We are from group IITL group. We want to present our big project about health analysis, which is about the KNN and then about the decision tree, about data processing and evaluation, and about naive Bayes. And in this section, let me introduce our group. My name is Adit Makrisos Thomas Dafu, and there is also Nazario Jose Valentin da Cruz, and then Anirudh Chaudhary and Muhammad Sahil. And let's do the next part. So for the introduction, in the healthcare domain, AIDS plays a crucial role in determining a patient's risk factors like medical history and treatment plans. And then for the accurate AIDS prediction based on simple health indicators can support early diagnosis and help tailor personalized healthcare strategies. Okay, next. And this is our data set. So the data set contains age, gender, and then dementia, all diabetes, hypertension, and many more. And for the problem background, we use the gender, age, and then diabetes status and hypertension status. Although these features are commonly available and easy to collect, it remains a challenge to determine whether they carry enough predictive power for estimating age. So now this is my part of the project. So this is data processing and evaluation. So first, we need to data loading and cleaning. First, what we have to do is loaded health dataset from main.csv, which is our dataset, and then selected for core features like age, gender, diabetes, and hypertension. And then we check the missing value and remove rows with missing values on to ensure clean data. And this is the picture of the missing value, which is zero missing value. And then this is for the feature encoding and target transformation. So we created a new target variable age group, like 0 is for the young, and then 1 is for the middle age, and the older is above 60, which is 2, and converted the task from regression to multi-class classification. So this is the classification. And for the feature splitting and scaling, we define the X is input features, all except age and age group, and then the Y is the target or age group. And then split data into training and test sets, like 80% training and 20% testing with stratified sampling, and apply standard scalar to normalize features. And for the class distribution analysis from this classification, visualize class distribution of age group, and then most sample fall into the older group, and class imbalance detected may affect model performance on minority age groups. And this is for the feature distribution before scaling. As you can see, the leftmost is for the female, and the rightmost is for the male, for the gender male. And then for the diabetes, the left side is for the no, which is not diabetes, and then yes is for the diabetes patient, and then hypertension for the left side is the not hypertension, and then yes, and the right side is the hypertension, which is which has the hypertension. So gender male is well balanced, and then diabetes is highly imbalanced, as you can see here, and then hypertension, yes, shows mild imbalance toward hypertensive patients. And this is after scaling. So plotted histograms of scaled features, and then all features centered around 0 with similar variance, and then ensure fair contribution of each feature to machine learning model. Next.
So now let's talk about the naive Bayes classification. So for the model types and evaluated in here, I implemented two types of naive Bayes classification, which is Gaussian naive Bayes (GNB), that we assume feature follow a normal distribution, and also the categorical naive Bayes (CNB), designed for discrete binary features. So first of all, let's talk about the Gaussian naive Bayes GNB. So in here, first I use the Gaussian NB, which is assumed that input features follow a normal Gaussian. So like we see in here, there's a train using scale feature, X train scale, and also we make the prediction on X test scale, and also the evaluated using accuracy score and classification report. So in here also we made the confusion matrix, but I think it's in the code. So after, when we have a time, we will show you the confusion matrix also. So next. So in here, there's also a categorical naive Bayes, CNB. So in here, actually, we also have a train using row unscaled binary feature X train. And also in here, we prediction were made on the X test, on the X test, and also evaluated using same matrix. We also using accuracy, classification, and also actually we have a F1 score, I think. And also the confusion matrix was visualized for the comparison between the CNB and the GNB. Okay, so here is the evaluation matrix. So for the accuracy score were printed both for models. So in here, as you can see, so for the Gaussian accuracy is around 0.36, while the categorical NB accuracy is 0.69. And also for the classification report precision, we have precision recall F1 score, which is for the F1 score, it's classified by the age group. So 0, 1, and 2, like Dafu said again before in the first slide. So in here, confusion matrix were made plotted by side using a heat maps. Actually, it's in the code. So in here, so for the example prediction, so actually in here we are looking for the example that we want to make is like how many male people can have diabetic and hypertension in what age. So in here we created a sample input, male, diabetic, and hypertensive. So in here actually for the male, most of them can get the diabetic and hypertensive in the older 61 age. So actually we calculated, then we get the accuracy before. So after that we can compare it into the other model. So I think that's all.
Hello everyone, I am Mohammed Sahil, a BCSE student from Chitkara University, and my role in this project was to implement and analyze the decision tree model. Next page. And our database includes simple but important health indicators like gender, diabetes, and hypertension. And we aim to predict the patient age group, either young, middle aged, or older age. We have set up the model, use decision tree classifier with maximum depth is equal to 4. It's the limit the depth to avoid overfitting. Criterion entropy uses information gain for splitting. Trained using patient features to predict age group. 0 is equal to young and 1 for middle and 2 for older. Next page. Next page. Next slide. And the
Okay,
decision
these three.
our model achieve an accuracy of 73% on the test data and making it the top performer in our experiment. And tree structure visualization is using plot tree. Each node shows splitting features and threshold. Example, hypertension number less than equal to 0.5 and class distribution at that node. Entropy measures of impurity, and is the graph of our decision tree structure. And next slide. And the important features, calculated importance of each features in the tree displayed using a horizontal bar chart. Most important feature contribute more to splitting decision. In conclusion, the decision tree not only gave strong results but also helped us to understand which features influence the predictions, making it a powerful and interpretable tool for this problem. Thank you. And this is our case prediction. Male diabetes and hypertension. For gender, male is equal to 1, diabetes for 1, and hypertension for is equal to 1. And prediction result 87.95% probability of being older, which is age greater than 60, very low probability for young or middle, and visualized using a bar chart of predicted probabilities. Next page. Thank you.
So, first of all, good afternoon, everyone. And as my batchmates explained you about their projects and their works, so my name is Anirudh Chaudhary, and I'm pursuing computer science engineering from Chitkara University, and I live in India. So, in this project, we analyze health data to understand and predict hypertension and diabetes using basic patient information like age, gender, and hypertension and diabetes dataset. So now we'll just do the slides one by one. So KNN model overview. We implemented using scikit-learn's K neighbors classifier. Default numbers of K neighbors K equals to 5, trained on scale features, X trained scale, and predicts age group classifications for which 0 is equals to young, 1 equals to middle, and 2 to older. We can switch to next slide. Okay, yeah. So model evaluation, accuracy and classification reports are printed on the screen. So metrics include precision, recall, and F1 score per class. So so we have also used confusion metrics visualized using heat map in Jupyter Notebook. Next slide. So accuracy and classification reports are printed as shown in slide, and metrics which are included are precision, recall, and F1 score per class. Confusion metrics visualized using heat map. We can get the next. Um, Tested K values from 1 to 20. Accuracy scores plotted for each K. Like in the graph, we have K versus KNN accuracy versus K value. So we have plotted a graph between the this KNN accuracy versus K value. So accuracy scores plotted for each K, like we have used K5 and for values 5 to 20 also. So helps identify the optimal K for the best performance. Okay. So we have used a real world prediction example. So we have sample input for male diabetic, hypertension, and we have used example like the code shown here, gender, which is male, diabetes, yes, and hypertension. And we have used code and preprocessed and scaled using same pipeline. Model predicts class probabilities across all age groups, which we have given like 0 for young, 1 for middle, and 2 for old. Bars are displayed for visual interpretation of prediction confidence. Next slide. And bar chart is actually given in the slide. We can say like in the Jupyter notebook we have sent to you. Next, summary of KNN behavior. KNN is a distance-based classifier heavily affected by scaling. Performance varies based on K values and class imbalance, which we can provide intuitive probability outputs for user-friendly interpretations also. Next. Okay, so we have also, in conclusion, we have also used model comparison for KNN versus naive Bayes versus Treziner tree. In this all models, KNN for KNN equals to 5, feature type is scaled, and accuracy test is 0.7322. And for Gaussian NB scale is 0.36, categorical INB, and decision tree. So the maximum accuracy was found in KNN and decision trees. So all models aim to classify patient info, age group 0 to young, which is less than equal to 40, age group 1, which is middle age 40 to 60, and age group 2 older than 60. So as we next slide. So as we conclude the whole project, so we have found that KNN and decision tree achieved the best accuracy. It's 73.22%. And categorical naive Bayes performed fairly well. It's 69.40%. And Gaussian naive Bayes had the lowest accuracy, 36.7%. So KNN and DT are recommended due to strong performance on this dataset. So in future, we have future scope for this project. Like we can add more attributes and more features in it. We can handle class imbalance and explore assemble models.
So
That's
that's
it,
all for our
Yonas.
presentation. So thank you very much and goodbye. Bye. Okay.